Hello and thank you for joining me again as we continue our discussion on energy. Today we're going to talk conservation of energy and how that works with mechanical and potential energies, or kinetic and potential energies, sorry. So your conservation of energy, when we say something's conserved, it means it remains constant. So your conservation of energy states that your energy before and after an action is the same. So the sum of your kinetic and all forms of potential have to stay the same. And this is mechanical energy. So mechanical energy is the sum of your kinetic and potential. And so mechanical is kinetic plus potential. And when we're talking about conservation, that means that your initial mechanical has to equal your final mechanical, which we're going to work on here shortly. So your two types are kinetic and potential shown down here. Non-mechanical is going to be things like friction. And you have different forms of potential, such as gravitational, elastic, we can talk chemical potential, things like that, are all forms of potential energy. But in this case, if we have a pendulum going back and forth, at the top, you're going to have all potential energy because it's not going to be moving. When you get to the bottom, because it's at the bottom, there's no potential anymore because it's at as low as it's going to go. So all of this is going to be kinetic. At this point, you're going to have all potential, and then here is going to be somewhere a little bit of both, which we're going to practice with today. For example, if you look at an egg falling, so the time an egg was falling is here, the height it fell from is here, and the speed is going with it. Your potential energy, again, is based on height. So this is based on a 75-gram egg. So my potential energy is going to be 0.74 to begin with. Notice I have no kinetic, and then my numbers gradually change. My mechanical is the total. So 0.74 plus 0 is 0.74. 0.70 plus 0.036 rounds up to 0.74. And as it goes on, you see that the mechanical stays the same all the way through. We are ignoring friction, but you get the point. And so the only time mechanical energy is not conserved is in the presence of friction. So for example, a sanding block slides along a piece of wood. The energy that we lose due to friction is given off in the form of heat, which dissipate into the block and the surface. And so that's where we lose our energy to, is heat. And that's, so we lose some of that kinetic and potential, and it goes into thermal. Well, let's do some practice with this. So for starters, so conservation of energy, we have, starting from rest, a child zooms down a frictionless slide from an initial height of 3 meters. What is her speed at the bottom of the slide? And assume she has a mass of 25.0 kilograms. So I'm going to write everything I know. For starters, I know she has a mass. Her mass is equal to 25.0 kilograms. I know the slide has a height of 3 meters. So I know h is going to be 3.00 meters. Now I'm looking for V at the bottom, so her VF. I don't know what that is, but because we're working with conservation of energy, remember your mechanical energy initial has to equal your mechanical energy final. And this mechanical energy is going to be your KE initial plus your PE, in this case the sum of your PEs initial has to be equal to your KE final plus sum of your PE finals. KE is 1/2 mv squared. In this case, we're going to have gravitational potential energy, so it's going to be mass times gravity times height. It's going to be equal to, again, this is VI, this is HI. So 1/2 mvf squared plus mg h final. Notice they all have mass. So in this case, if we're not looking for something like speed, we could cross off your masses. We can eliminate some things, but for now we're going to leave it. Okay, so I'm trying to find her speed at the bottom of the side. I'm trying to find this VF. That's my goal. Now, when she's at the top, notice she starts from rest, which means my VI is going to be 0. Because VI is 0, that means that my kinetic energy is going to be 0. So in most cases, one of them is going to be 0, either your kinetic or your potential. Not always, but a lot of times. So I know that my kinetic is going to be 0. If I'm looking for her speed at the bottom of the slide, when she gets to the bottom, how far above the ground is she? Well, she's not. So my H final, this is going to say it's H initial, my H final is going to be 0 meters as well, which means this is going to be 0. So I can cross that off. So I know that my initial potential energy is going to be equal to, well, my GPE initial is going to be equal to my KE final. So now I can do some math. I can take my mass times gravity times height equal to 1/2 mv squared. And I get 25.0 kilograms times 9.81 meters per second squared. And my height was 3.00 meters. This is going to be equal to 1/2, again times 25.0 kilograms times v squared. So if I wanted to, I could cut my 25 kilograms on both sides. I don't need them, they're extra, it's there. So I have my 9.81 times 3, and it's equal to 1/2 times v squared. Multiply this side by 2, so I'm going to put 2 on this side, I'm going to cross this off, and I'm going to take the square root of everything, which is going to get rid of my squared over here. So if I do all of that, I take the square root of 2 times 9.81 times 3. I should get 7.67. My VF is going to be 7.67 meters per second. And that's how we do conservation of energy. Okay, on the next couple slides, I have practice questions for you. So when I get to a slide, for example, this one, here's your first practice question. A bird is flying with a speed of 18 meters per second over water when it accidentally drops a 2-kilogram fish. If the altitude of the bird is 5.4 meters and friction is disregarded, what is the mechanical energy of the system and what is the speed of the fish when it hits the water? In this case, I would ignore the mass of the bird to deal with just the fish and the speed of the fish when it hits the water. So pause your screen, try that question. I'm going to show you 2 more after I give you the answers to this one. So here's the first answer. Second question is here. So a 755 Newton diver drops from a board 10 meters above the water surface. If the mechanical energy of the system, find the mechanical energy of the system, and find the diver's speed 5 meters above the water surface. Then find his speed just before striking the water. So you should have 3 answers on this one. So work through this, get all 3 answers, and then hit the play button, and you'll get your answers. And check yourself. And the last one. A pendulum bob is released from some initial height such that the speed of the bob at the bottom of the swing is 1.9 meters per second. What is the initial height of the bob? So again, pause your computer, work through this, and I will show you your answer now. So those are some practice questions. We'll do some more work with it in class. If you have questions, please come see me. If not, I look forward to working with you more as we continue this, and enjoy the rest of your day.